Welcome back to digital class, and now we're looking at one of the more exciting pattern concept that's called the type 4 different figures. Now, when I say different figures, basically means there are really just so many different figures. So some of the examples of the question can be something like this, where I give you something like this, figure 1, 2, 3, and you need to find out what is missing. Or you can see some figures like this, then you need to find out some of the information. It can be like this, different figures here, different pattern of figures here. It can be even something like this or this. Now, some of them use the word pattern, some of them use the word figure, but that doesn't really matter. But the style of the question is that they will always give you something like this, and they will ask you to find something. This is what I categorize it as the pattern concept, type 4 different figures. And you will notice that, Mr. Law, then why is your notes so interesting? Is that arithmetic sequence, triangle, what's that actually about? Now, because there's just too many different patterns that you can find in this concept, I actually would like you to follow the sequence here. These are the things that you should check every time when you are doing different figures question. So example up here, I say the first part, is there a link between figure number and the given numbers? Now, for example, what I'm actually asking you to do is that when you're looking at this is pattern 1, which is figure 1. This is pattern 2. This is pattern 3, which is figure 1, figure 2, figure 3. Is this number or figure number linked with this? For example, is 1 times something to become 6? 1 times 6 becomes 6. But is 2 times 6 become 12? No, it's 11. So I want you to see is there any link here? Or another example is that what we can do is you can look at here. Now, this is the figure number 1. This is figure number 2, 3, 4, 5. Now, is there a link between this and this? Now, if you see, 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 8. It's not 6. 4 times 3 is 12. It's not times 2. Now, is there a link? No, not necessarily it has a link. So this is something that I want you to check every time before you actually start doing the question. And the second thing that I want you to check is there an arithmetic sequence here? Now, what does it mean by arithmetic sequence? Arithmetic sequence is this, which I will talk about in a short while. The next thing that I want you to check is there a triangular number sequence here? What is triangular number sequence? Which we will talk about it in a short while. Is there a perfect square pattern? Now, what is perfect square? Again, we will talk about here. And last but not least, is there a pattern involving odd and even number? And this is something that's very important as well. Okay, so let's talk about arithmetic sequence. Now, I know that it's a bit scary to see all this formula, all these things. Now, let me just talk about the example first. Now, this is the first example. This is the second example. Now, you can see here, 4, 7, 10, 13, 16, 19. So there is a sequence here. There is a number sequence here. But what is special about this sequence? Now, if you observe carefully, you'll notice that, 4 plus 3, 7 plus 3, 10 plus 3, 13 plus 3, 16 plus 3. Okay? Everything is plus 3, plus 3, plus 3, plus 3, plus 3. And that 3 that is repeating, adding in, is what we call it as the common difference. The common difference. Why? Because 7 minus 4 is 3, 10 minus 7 is 3. So that is the difference, and it's common, is what is repeating here. So what I need to do is you first recognize what is the D. So here's 3. N. What is N? N basically is what you need to find. The N term. Basically, in this case is what? 20th. This is what you need to find. The N. What does this 0 figure means? Now, I know, this is the first, this is the second, correct? This is the third number. Now, with that in mind, if I will have to have a zero term or the zero number here, what will be that number? I think as you know, we are plus 3, right? So here will be probably what? 1. And the zero figure basically means the number before the first number given, which is what? 1. Now, that is basically called the arithmetic sequence. There is a plus 3, plus 3, plus 3, plus 3, plus 3. Teacher, can it be plus 4? Can. Plus 4, plus 4, plus 4, plus 4. Can it be plus 10? Can. Plus 10, plus 10, plus 10. Now, what is important about this sequence? This sequence actually gives us a very interesting thing, that when we are able to use this formula that's given here, we are actually able to find the 20th term here. We can even find what is the maybe like 321 term here also. Teacher, what do you mean by term? Term is the zero term, first term, second term. Basically the numbers lah. This is the first number, second number. I want to find the 20th number in this list. So how do I find the 20th number? This is the formula that you are given here. dn plus zero figure. Teacher, what does it mean by d? D again is this 3. How about this n? N is 20 in this case. dn basically means 3 times 20. dn means 3 times 20. Plus, so you just plus. Zero figure is 1. So it's 1. So 3 times 20 is 60. 60 plus 1 is 61. And what I would like to tell you actually is, in the 20th term, the number that you will see is 61. So far, so good. Again, in the 20th term, the number that you'll be seeing is 61. Now, how about if I want to find 321 term, 231st term? There will be d. D will be what? Still 3. What is the n? 321. What is a zero figure? Your zero figure is still 1. And again, you will follow this formula. This formula tells you what? D times n, which is 3 times 321 plus 1. dn plus zero figure, which is 1. So in this case, it will be 3 times 3, 9, 3 times 2, 6, 3 times 1, 3, 3 plus 1, 4. So in the 321st term, the number that you'll be seeing is 964. Okay, so I hope you get an idea of arithmetic sequence. Now let's move on and look at this another arithmetic sequence. Now, if you look at here, 6, 11, 16, 21, 26, 31, what does that mean? You will see that this is actually adding what? Let me use green color just to help you to differentiate clearly. You will see that it's actually adding 5. I plus 5 here, I plus 5 here, plus 5, plus 5, plus 5. So the common difference here is 5. Very good. N means that what we want to find, which is 500. Zero figure. If I were to have a number in front of 6, what would that number be? In this case, because I'm plus 5, it will be 1. Okay, so is coincidental, is incidental that this is 1, this is 1. It's not always 1. Now, again, the formula is here. D times n plus zero figure. So d is what? 5. What is my n? 500. What is my zero figure? 1. So it will be 5 times 500, 2500, and plus 1, 1. That will be basically the 500 term. Okay, I hope you get the idea. If you feel that it's slightly difficult, feel free to go online and look for videos that's about arithmetic sequence. Okay, now this is just one of the formula that we can use to find. There are actually still more out there. Okay, now the second sequence that we are learning is called the triangular number sequence. Now, different from arithmetic sequence, we have different example. Right? This example is plus 3, plus 3, plus 3, plus 3. This example is plus 5, plus 4, plus 5. Triangular number sequence only have one sequence. Again, I repeat, triangular number sequence is only have one sequence, which is this sequence. Okay? There's no other number sequence already. It's only this one. This one, we have different example because I can plus 2, plus 2, plus 2, plus 2, plus 6, plus 3, plus 8. I can have so many different. But this one, only one. Teacher, then why is it so special about this triangular number sequence that is only one? Because this is like this. Plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9. Do you notice that? This is actually plus 2, plus 3, plus 4, plus 5. So this is actually something that is interesting, and this is called triangular number sequence. And the formula basically is very simple. N is what? Basically the one that we want to find. N times n plus 1 divided by 2. So in this case, what is my n? 15. So in this case, what I would like to do is 15, this parenthesis means times 1 more than 15 is what? 16, no? So 16 divided by 2. So 15 times 16 divided by 2. And that's equal to what? That's equal to 120. How about this second example here? I have 25th term. My n basically is what? 25. So that basically means 25 times 26 divided by 2. And that's equal to 325. How about the 100th term? The 100th term basically means n is 100. So there'll be 100 times 101 divided by 2. And the answer is 5050. And now, teacher, this 15th term, 25th term, 100th term means what? Now, this 1 is actually the first term. This 3 is actually the second term. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the 9th term. So if I continue and I found the 50th term, that will be 120. If I continue, I found the 25th term, that will be 325. If you continue, and maybe the 100th term, that will be 5050. Now, teacher, you may be thinking, teacher, why is it so important to know the formula? Because if I give you, find the 335 term, do you want to go and plus 2, plus 3, plus 4, plus 3, blah, 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 plus until you go and find out the answer? No, we will actually use the formula, and this will be so much faster. The same thing for arithmetic sequence. By using the formula given here, you can find it faster. Okay? Now, you may not be understanding why are we learning this. It seems like we never really learned something like this in our textbook. But this is very useful. When you know this, when you solve the question, it will be so much easier. Okay? Which you can see from the example and from the questions later on. Now, perfect square. What is perfect square? Again, this is something that you have learned from me many times. Perfect square basically means that like 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. So all these numbers that I circle, they are all perfect square. But of course, there are more than that. We have 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, 10 times 10, 100, and so on. And more. Okay, but these are the numbers that you should notice. Okay, because by knowing this, you will know immediately this is perfect square, and we can solve things easier and much faster. Okay, and last but not least, we have this odd and even number. Now, figure 1, 2, 3, 4, 5. Just like what you see here. Pattern 1, 2, 3 is the same thing. Figure 1, 2, 3, 4, 5. Now, all these things, I would like to remind you that sometimes you need to recognize 1, 3, 5. They are odd number. And next, we also have what? 2, 4, 6. All of these are called what? Even number. Teacher, why do we need to really know odd and even number? I mean, for sure we know, but how does it help us with this? Now, sometimes the odd number or the odd number actually holds something very special. And some of the even number holds something very special. Like example here, and probably figure 6 here will actually have something that's more interesting, that they are actually connected. And maybe the odd number here, they have their own things that actually connected. And by recognizing that, you actually can see something very, very important. And by knowing all this, and by checking through all these lists when you are looking at that question, you will make things so much easier. Okay, so I have 2 more notes and example here, and I will talk about them in the next video. So feel free to watch the next video so that you know how are you able to apply what you have learned just now in the previous page in the rest of the questions here. Okay, and I will just stop here and thank you. See you. Bye bye.